I've been a water treatment consultant for about 8 years, and I work with various companies like Pure and Brita on how they formulate their product. And I'm going to talk tonight about bottled water versus tap. What's better for you? How do we decide? All sorts of ramifications about that. But before we get going, I'm looking for some volunteers. Who is thirsty? We got one there. Two, okay. Does anyone here drink bottled water regularly? Somebody in the back corner that's hiding. Are you thirsty back there? You do? You do drink it regularly. 3, and Jason? 4. I need one more volunteer, actually. 5, okay. Did you see those 5 people? I didn't see those. Okay, raise your hands up if you're those 5 people. We'll find out. So these 5 courageous people are going to be taste testing water for us tonight. So let's pray, have a moment of prayer for them. Hope they survive the tasting. What you have in front of you is some different water, and I'll go into it in a second. But I'd like to start by reading you a poem. A poem from the back of Smart Water. This is I do this to just demonstrate how water is now marketed. Is it just us, or do clouds get a bad rap? While we admit they're not as great to have around on a beach day as, say, the sun, clouds are unsung heroes because they contain nature's purest source of water. That is not true, by the way. That is absolutely not true. Apparently, Smart Water has not heard of acid rain. But meanwhile, spring water comes from the ground and contains random stuff and whatever else the animals that swim in it leave behind. That's why we've copied our white, puffy friends by creating Smart Water. I just love, you pick up any bottle of water and they'll have a little wrap for you on the side. Whole Foods has the best assortment of ridiculous poems on the side of their water. They now have something called Oregon rainwater, water that never touches the ground. So you know it's pure. But I actually want to start by asking you this question. I want you to fill in the blank. Water is. And just shout out your answers. Essential. 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 Keep going.
Wet.
Wet.
Clear.
Clear.
Mostly.
Say that again?
Mostly.
Mostly.
The world.
Oh, mostly water. Okay. Water is. Keep going.
Source of life.
Polluted.
Or
Source of life, I heard.
Odorless, tasteless, depending.
Odorless, tasteless.
What we're made of.
What we're made of.
Underappreciated.
Underappreciated.
Overpriced.
Overpriced. Overpriced.
What was scarce?
Scarce. What else?
Renewable.
Renewable. There is no wrong answer here, by the way. Well, I'm sure somebody could give a wrong answer, but hopefully not. Just a couple more. Water is.
H2O.
H2O. I'll give you that one. All right, so everything you said is right on, but for tonight, for the rest of the talk tonight, I want you to consider it in this vein. Water is a choice. And I want you to think about it from the perspective of choice tonight. That every time you open your tap, every time you buy a bottle of water, every time you take a shower, every time you go to the bathroom, you're making a choice about the water that you're using. And if we view it in that vein, we're going to start taking a look at all the factors that go into that choice. And take a look at each vote. For tonight, we're going to look at 5 different factors. We got, does anyone want to guess what factors I'm going to take a look at tonight? Just name some.
Health.
Health. That is actually one. We're going to talk about health in terms of long-term health tonight.
Cost.
Cost, that is actually one of them.
Politics.
Taste, 3 for 3.
Politics.
Climate change.
Climate change. We're going to span that out to just environmental impact. That's 4 for 4. Who wants to finish it off?
Politics.
Politics? No, we're not going to do politics. I'll leave that to the experts. Last one is convenience. And there is a 6th one. We'll call it safety. And but before we get to all of that, have my water taste testers finished drinking their water?
We're what we're supposed to do?
Yeah, oh yeah, drink your water. Sorry about that. Drink your water.
Drink it or taste each one?
Taste each one. However you want to drink. If you want to drink the entire little bit, if you want to just sip it, if you want to spit it out, however way you want to drink it.
And
Try each one.
there's a letter, so pick the
Yeah.
favorite. Or
What are we supposed to do?
When there's a letter on the bottom of each of your cups, I want you to rank them in terms of your favorite.
Oh, that's...
Okay. Well, while they're doing that, we're going to talk about safety. Safety, as I define it, is if you drink water within the first 48 hours, you don't get sick and die. We can talk about it in that vein. In the U.S., there hasn't been an outbreak of waterborne illness in a large scale in 15 years. Actually, it doesn't sound that long, but that's the last time there was any sort of waterborne illness breakout. It was in 1993 in Milwaukee. There was something called cryptosporidium that infiltrated the water there, gave people lots of diarrhea, a few people died. That's the last time there's been any sort of major situation in the U.S. Abroad, that is not true. The estimate is something like 1 billion people don't have access to clean and safe water around the world. So just to kind of put things in perspective, when I'm going to, for the most part, ignore safety tonight, because generally speaking, everyone here in this country has incredibly safe water, as I define it. And to put things on a little more perspective, we live in a very prosperous nation. A lot of the world doesn't have access to clean and reliable water. The Darfur conflict, in large part, is a conflict over water. We take for granted that when we turn on our faucet, water comes out. There are people in nations around the world, even India, which is prosperous and booming, that spend upwards of 33% of their gross income on water. I don't think anyone here spends more than probably a couple $100 a year on water. What do you guys spend on water per year? Anyone? People don't even know how much they spend on water a year. I fathom to guess that means it's less than a few $100.
when you say that, is that people or the government spends that?
I'm talking about individuals.
Okay.
And are you talking water bills, I mean landscaping and all those things?
I'm talking about cost to you as the consumer. So that's what you pay out of your pocket. So when I was talking about that individual in India, he's paying out of pocket 33% of his income. And we kind of don't have to think about it. So that's kind of the perspective. Are you tasting your water, Tom?
I did.
Okay. Do my water testers, have they ranked them? Everyone finished? Okay, we're going to start over here. What was your favorite? What letter?
B.
B. And do you have any comments about it?
Not really.
Not really. Why was it your favorite then?
I don't know. I just kind of tasted the two and decided which one of those two I liked better and went through them. And I felt like some had more of a taste that just didn't go through to me.
It had a little bit more of a taste. Is there anything that was bad?
No.
Nothing that was bad. Nothing tasted bad. Nothing was offensive.
I didn't spit anything out.
No, you didn't spit anything out. So if you...
This is my favorite. Actually.
That's your favorite. Beer is my favorite too. So was B a clear winner? It was all kind of close.
Yeah.
All right, the next taster, right here. What was your favorite?
So E was my favorite.
E was your favorite.
However, it's because it tasted sweet.
E tasted sweet.
I think there might be something added to it.
Okay. Did you have any losers of the group?
Yeah. C?
C you didn't like. Why didn't you like
I
C?
don't know, it tasted either metallic-y or chemical-y. There's something,
Okay.
it didn't taste good.
Yeah, I didn't put any chemicals in it, so you can't blame me.
Tap.
So it's metallic or metallic-y and what else? Chemically, is that the word you said? Okay. Next tester. Right up front.
When I first tasted them,
Try using the mic so
sorry. When I first tasted them, I thought they all taste the same. They figured us.
well,
It's probably all tap water.
mhm.
The second time I thought I did actually notice one or two that tasted a little sweeter to me.
Which ones?
Well, I'm not sure.
The letters on the bottom.
Yeah, I know.
Yeah.
But I'm still wondering if you didn't just stick a bunch of tap water and all that. I'm wondering.
Well, you gotta have a little trust in me that I didn't do that yet.
Obviously.
You didn't do that.
Okay, so yes, C kind of tasted
See, a little
best
bit.
to me, actually.
But it's pretty close with you.
And this E one was also kind of sweet, but I'm not sure. I mean, it wasn't that big a difference for me. But I have a terrible cold, so
Okay.
I'm probably a bad person to test.
I think people get cold, so they drink water.
Okay.
We have 2 more people, right?
I have the same experience as this woman here.
Yeah, the same experience. That means
C was good, C was bad.
C was bad, E was good. Okay.
And the rest were,
And can I ask you, why was it bad or why was it good?
there was a different C that was, I can't describe what it was, but it was just different than the rest.
So it was different. C was just different.
Like there may be some minerals or some other components in there that weren't in the other one.
Okay. And our last tester.
Yeah, so I also chose.
I chose D as my favorite.
D
and
is your favorite.
C is my least favorite.
C is your least favorite. So, generally speaking, a big fan for everyone that trusted me enough to drink water. These are the 5 waters that are involved in the tasting. I'll show you. There's Fiji, which is artisanal water from Fiji. There is Aquafina, which is purified tap water from Fresno. That's where it's coming from. There's Smart water, which is vapor distilled. They actually boil it and distill it back down. Add electrolytes to it. There is this one that I found at Target. It is it's Gleneagles spring water from Scotland. It's in a glass container. And this is the tap water from right there, behind it, at the front of the bar. So, generally speaking, I've done this kind of tasting a number of times. What happens over a wide swath of individuals, if you start to get like 15, 20, 100 people, sort of evens out. No one really has much of a preference versus one or the other. Here it seems like C is sort of the loser of the group, but you like C up here.
That was my favorite.
What I'm trying to point out is individuals may have preferences, but when you sum it up over a large group, it tends to blank out, as long as there's not something particularly offensive. So, what do you guys think was C, which is the loser and the winner? Any guesses?
C was the smart.
C was Smart water is one guess.
With the electrolytes in it. Aquafina might have been B. Oh, yeah.
Which one do you think tap water is? How about that? B.
D, D,
D as in David?
no, the good one.
E.
When you say tap water, was it out of the filter? Or?
Yeah, it was either filtered right here.
Oh, filter, is it filter?
I think that's filtered right there. It's filtered tap water.
Oh.
Oh, you get me, I'm not being precise today. Okay, so Fiji was A. Aquafina was C. Smart water was D, as in David. That makes the Scottish water B, and tap water was E, the filtered tap water. What does this prove? It proves nothing. That's right. It proves absolutely nothing. It just
Taste
shows
buds
that
are all
it.
different.
What's that?
Taste buds are all different.
Taste buds are all
But
different.
isn't Aquafina filtered tap water, you said?
It is. I'll go through what each of these are right now before we go on. Artisanal water is water that comes from a source that's deep within a rock. It's an aquifer that rises through rock, so it's naturally filtered through rock, and it bubbles to the surface. Now, what they don't tell you is that there has to be an artesianal spring that rises to the surface within about, it's rough to say, but it's about a kilometer of where you bore a hole down into that artesianal surface. So it's not, don't picture it as bubbling up and then they kind of package it. There's an artesianal source and then they drill a hole down into the water and start bottling it. Aquafina, like I mentioned, is tap water that has been filtered. But what's the reaction to that when I mentioned that? Did people know that? No.
Those were the two sweet ones.
So it's unfair to just call it tap water because it does go through a rigorous processing. And it essentially goes through first like an RO system, large-scale industrial RO system. Then it goes through like an activated carbon system. And then Aquafina just gives it to you straight Dasani, which is also purified tap water. They add minerals back to it. And this is buying water from the municipal water, MWC down in LA, is what they're called. It's buying water directly from them. Smart water is, like I said, it's distilled and they add electrolytes to it. And by electrolytes, I mean they add magnesium and calcium to it. They add some salts. This spring water means that there's a natural aquifer that just bubbles to the surface. So imagine just walking through the forest and you see water just kind of bubbling out of the ground. That's what this is meant to be. Again, they dig a hole somewhere near the spring, make sure that the water tests about the same, and then they call it spring water and package it. And lastly, tap water. Who knows where our tap water comes from? That's absolutely right. Hetch-hetching. Where does the water come from in hetch-hetching? Is it just kind of there? It's what? Snow melt. Okay, so spring water and snow melt are remarkably similar. Crystal geyser is actually snow melt water that they call spring water. Snow melt melts, goes into the rock, bubbles back out. They call it spring water. So I think what you're technically drinking with the tap water is spring water that goes through a big pipe. And they call it tap water. So that's the distinction in the waters. Is there any questions about the waters? Those are 5 kinds of waters.
So what does it acquire as it travels down the pipeline?
What does the water acquire as it travels down the pipeline? What do you think it acquires?
I don't know, maybe some mineral cast-offs from the pipe.
Cast-offs from the pipe.
Fluoride.
Fluoride.
Chloramine.
Chloramine.
What else?
Well, I'm asking you.
I don't know, I'm asking you.
What else do people think it gets acquired as it kind of, before it arrives? What is that? A lot of bacteria. Anything else? Algae maybe?
Some people have mentioned concern for lead in the pipes in your home that might be leached into the water.
Okay. All right. Those are all right. I mean, there's a big pipe. Water goes through it. It's no different than any pipe anywhere. Generally speaking, the concentration of metals that we're talking about here are very low. You can read it at sfwater.org. You can read the actual readout of what the mineral testing is. They actually test at different sites around the city, like out of a tap. They have to, by law, test at the effluent source, like what you're technically drinking. They won't publish where that is, though. They just tell you that they're pulling water from a tap somewhere, but they won't tell you where. They do add fluoride and they do add chloramine. So you're 100% correct.
Chloramine, right?
Chloramine, yes. What did I say?
Chlorine. Isn't
said,
it different?
Yeah, I said chloramine.
Oh.
So let's start getting into the factors. What do you guys want to start with? Environmental, convenience, cost. What is some?
Real quick question. You said that the one of the waters was RO treated. What's that mean?
Reverse osmosis is basically a. Does that answer your question already? Okay. It's a polyimide filtering mechanism, which is a nitride polymer or nitrogen-based polymer. It basically has holes the size of a water molecule. What you do is you basically put your dirty water on one side of the membrane, create pressure, push only the water through, and you leave some water behind with the stuff that's not the size of the hole on the other side. And then you sort of purge it by flushing it out, flushing out that sort of wastewater. So RO has benefits in that it produces very pure water, but it also wastes a lot of water in that you have to flush out those deposits with water. That's what RO is. So environmental, cost, convenience, taste, long-term health. What do you want to start with? Taste. Okay. How does your water taste? Do you drink tap water at home? Well, first of all, where do you live?
In the Castro.
In the Castro. Do you drink tap water?
Brita.
You drink a Brita water. Why did you buy a Brita filter?
Because I thought that it would filter out something that might not be good for me and make it taste better.
Did you choose it because of taste? Is really the question I'm asking.
I didn't compare it with any other
filters.
Do you think it tastes good coming out of the rare filter?
Yeah, I think, there's a little fantasy that it's smoother. I can imagine all the little charities being caught in there, and I feel the velvety texture.
Feel the velvety texture. That sounds like a joke, but literally on the side of a Fiji bottle, it talks about mouthfeel. So let me ask you this. Should water taste like anything? Should water taste like anything? Should it have a taste?
Yes.
Yes. What should it taste like?
Slightly of the minerals and salts that are in the ground that it comes from.
Slightly of the minerals and salts of the ground it comes from. Well, who else thinks that water should have a taste? You would like it to have a mineral taste a little bit. No one? What about the purists? Who wants water to just be water and nothing else? There's a few people that feel that way. That's generally how it goes over large populations. Some people think that minerals should be included. Some people think that it should just be water. I'll come around to you in a second. What I have to say about that is I believe in this crazy thing called evolution. Have you guys heard of this? It's kind of in debate right now, but it's right or wrong. But I think from an evolutionary standpoint, we drink water that naturally would have some mineral content to it. And that we grew up accustomed to water having some content in it. Generally speaking, that would be calcium and magnesium, maybe some salts in it. So I do think water should have a taste. But it's a very individual preference. There is no standard like, here's what water should taste like. There is a standard of here's what Coke should taste like, here's what a good beer should taste like. Well, at least I think so. Maybe the people at Budweiser do. But what's your question?
What about the dissolved gases, like air, oxygen, or carbon dioxide in the case of fizzy water? I mean, the gases that are in the water.
So your question is about dissolved gases in water. You think that imparts taste to it?
Well, I mean, like, for example...
In your experience?
Well, things of water that is slightly carbonated and has that, fizzy kind of water taste. I know waters that have more air that had a lot of air driven into it. So the air also probably imparts the taste of the water or something.
So the question is, like, obviously carbonated water does not taste like non-carbonated water. So I think we're going to talk about it still to still at this point. Generally speaking, aerating the water does have an effect on taste, but not because there's more oxygen in it. The studies have shown that it's because it affects the effect of chlorine on the water in the case of tap. But generally speaking, unless we're talking about hydrogen sulfide gas dissolved in water, aeration doesn't make a huge difference in taste for most people. Oh, you have a question back there on taste?
Yeah, I guess, well, here in the city our water tastes good, but I've worked in Pleasanton and you couldn't even drink it. And I've seen like water come out of springs that actually taste salty. Mm-hmm. And I've had other water that's kind of metallic. But the worst I think is, I don't know what was in Pleasanton's water, but it was awful.
What did it taste like?
Yeah, I don't remember.
You don't remember. It was just bad. Metally. It was just weird. Who's not from here? This is a great question to ask in San Francisco. Like, it's always going to be like a huge percentage. Who grew up where water was, lack of a better term, shitty?
Oh, I used to live where it was terrible.
Where it was terrible. What did it taste like where all these places there was terrible? Would you drink it? Was it drinkable or is it undrinkable?
No.
Undrinkable. What about you, Jeff?
It was drinkable, but it didn't taste very good, and probably knowing that it came out of the Ohio River didn't help the taste.
Okay, he's from Ohio. Or Pennsylvania?
Ohio, yeah.
Ohio, okay. Well, a river that catches on fire can't taste that good. But who else grew up somewhere that the water tastes like dirt? No?
Well, I lived in Arizona. It was gross.
It was gross.
Yeah.
So this tends to be the general assumption. Like, water here tastes good.
Yeah.
Water in other places tastes
Barcelona,
bad.
it was so bad. It's so heavy in minerals. There's so much lime in the water in Barcelona, you can't drink that.
The biggest taste factor that most people cite is something called TDS, or total dissolved solids. This is the one that everyone points to. You'll see it in the analysis at SF Water site. You'll see it on a lot of the bottled waters here. It generally points to minerals like calcium, magnesium, salts like chlorides, bicarbonates, and some nitrogen-containing compounds. Those are the most flavor-inducing compounds. There are lots of compounds that are nefarious that taste like nothing. But these are the ones that impart a lot of taste. Generally speaking, TDS at the concentrations that we're used to, even these places that taste bad, has not been shown to have any significant health effects. What it has been shown is above about a concentration of 500 ppm or 500 milligrams per liter, that it becomes undrinkable. The San Francisco water is 100 milligrams per liter or 100 ppm. Fiji water is 200. It tends to be that San Francisco tap water has a lower TDS number than any of these other waters here, except, well, the Smart water technically had less, but then they added some back in. But so these guys are playing on the assumption that water should taste like something, and that's generally the way people feel about it around the world. So that's what I have to say about taste. If you're worried about taste of your water, look at that number TDS on your report, whether on the side of the bottle or not.
You didn't ask about people who love the water they grew up with.
Love the water. Who loved the water they grew
Well,
up with?
what was interesting, New York, the water is really good. And
New York City?
New York City. I didn't even actually believe it until I moved away and lived in Florida for a while, where the water was horrible, and at least to my taste. And then when I went back to New York, I was actually surprised when I picked up a glass and, I wasn't even thinking about what the taste, and I said, now that's water. Now part of it is I was imprinted with that water.
Well, New Yorkers still live. The world revolves around Manhattan, so.
Right, but they say that the reason that bagel's going to taste the same is because they're outside of New York isn't the water. So,
Fair enough. What I want to highlight, though, is the people that said it tastes bad. Did you, like, the way, your comment about Pleasanton, will you ever drink Pleasanton water again?
I might try it again, but if it tastes the same,
Yeah, like, it's a huge turn-off taste in terms of your water experience. That's why these guys are so protective of their recipe on water, because they're very interested in their brand protection. So, taste, huge component in your choice, they know that, and they act like it.
Is any of the bottled water available actually just pure water without anything added?
The question is any of the bottled waters just water? There is a number of waters that are like incredibly close. There are distilled waters on the market that are very close. Aquafina is actually really close because they don't add anything back in after their processing. So yes, there are waters on the market that are just water. If you get a really pure water, it's going to actually taste a little acidic, and you won't like it. If you get a really high purity water, but it'll be really expensive, so you won't even buy it unless you have a millipore system. No. Okay. Moving on from taste. What's the next category you want to talk about? Cost, environment, health. All right, health. What do you want to know about the health?
how much stuff leaches out of the plastic container into the water.
First question I always get, plastic bottle, what is it leaching? What is it not leaching? What else about the health?
Growing up, there was a scare of industrial pollution in the water, and even though the actual risk was gone in about a week, people were afraid of it for years afterwards. And I hear stories in San Francisco of people wondering the San Francisco water because many years ago there was some pollution in it of some kind, even though it tastes really good. So I think the fears of water are going to linger for a long time, and I'm curious how people can get really accurate information about how safe the water is.
Okay. So, do you remember what the industrial pollutant was that was in the Ohio River? The one industrial effluent that was in the Ohio
The one
River?
they talked about was
Yeah.
carbon tetrafluoride.
Okay, CCl4. That's a nice. That's a carcinogen. It's classified as a carcinogen by the FDA. It tastes really, really bad.
On the same, right on the tagging on that question.
Yeah.
There's a lot of talk about all the chlorates on the rocket fuel that actually are in every well in California now.
So there's a lot of your questions wrapped up around industrial pollutants that will show up. Great, I'm going to address that too. Most of those are organic in nature, so we'll come back to that. Other health concerns about your water in the back.
I think not necessarily here in California, but you hear the more recycled wastewater, pharmaceuticals that have been recycled into water, small molecule pharmaceuticals. And also, I've been reading recently that the source of fluoride has been coming from industrial waste products.
Okay, so that's three different ones. There's recycled wastewater, where they take what goes down our toilet, turn it back into potable water. 2 is pharmaceuticals in our water, and 3 is the actual fluoride used. Awesome. Anyone else? Health effects.
Like the intentional additives, chlorine,
Chloramine, the fluoride, the chlorine. Anybody else? Okay, so we're going to find out. What do you think is the worst pollutant in the water? What are you scared of the most? What was that?
I said, no, I just made a joke.
Tylenol. Mercury. Lead. Radon. Yeah, radon's not very soluble in water. The one I hear the most is actually right now is the plastic bottles. So let's take a look first. We'll put 2 different kinds of plastic bottles up first. We'll come back to carbon tetrachloride, which is an interesting situation. Okay. Does anyone know what plastics these are?
polypropylene on them or not?
It is not polypropylene. It is not PVC either. The Fiji bottle is made out of PET. You can identify it by the number 1 recycling code on the bottom. It's polyethylene terephthalate. It is a multi-stage processing plastic that's made from 2 different components of petroleum, 2 different byproducts of petroleum refining. So how the life of it is, you start out, you bring a barrel of oil into an oil refinery, you process it, you make 2 different additives, then it gets shipped off, 2 different products basically, byproducts. You ship those off to another manufacturer who mixes them together to make a resin, which is now the PET resin, which then gets shipped to the bottler, which heats up the resin and forms it into a bottle, and then fills it with stuff after it cools down. So it's a multi-stage process. We'll get to the health risks in a second. This is polycarbonate, which is a different kind of plastic. It is the number 7 code on the bottom, recycling code. These are the 2 that are most commonly used for water. These are the Nalgene bottles that we all come to know, and PET is everything from soda bottles down the line. So, this one, the health effects. There are 3 major health effects. Does anyone know what they are? 3 significant ones. Go ahead.
PCBs.
PCBs. What else do you think of? Phthalates. Okay. Anyone else know what the other... PCBs are not associated with PET. Plastic are not. NOT. Phthalates are. We'll come back to phthalates in a second. Other 2? The other 2 is antimony trioxide, and the last one is which is the most dangerous one in my opinion, is just bacteria from reusing the bottles and not washing them out properly. Because what happens when you just let water just sit there for an extended period of time? It gets stagnant and grows bacteria. So we'll talk about the phthalates first. There is a chemical in here called DEHP, diethylhexylphthalate. And what it has shown in laboratory rats is that it causes some sort of damage to their liver and kidneys. And high doses. Not the kind of doses that we are exposed to, weight to weight. But that's where the concern comes from around phthalates at this point. Now, in terms of this leaching phthalates into the water, That generally they see a higher incidence when you do a couple things. When you reuse them, that's why it's always advertised only use those bottles once, never reuse them. And and that all comes from not just, general use. It's not like when you pour in water the second time, something magically happens. It's just from wear and tear, like dropping the bottle, scratching the bottle. All these bottles are coated with basically a protective barrier. It's actually aluminum, but we'll get into that. That becomes really complicated in a hurry. But essentially, as you scratch off the coating and damage the bottle, it can leach more material into it. That's why it's always advertised single use. In terms of threat risk, I can give you my opinion. The research is not to the point where it proves anything, any sort of damage. It's only at high doses right now. There are not a lot of low-dose studies of DHP.
Also, if you leave it exposed to sunlight.
That's the other point of concern. She just mentioned sunlight. DHP leaches more at higher temperatures, higher exposure to UV rays, and higher acidic compounds inside. What that means to you, though, is that only affects you if you're reusing the bottle, a significant amount. So, if you care about DHP, but on the scale of things, this is pretty minor, I would say. This is on the level of drinking muddy water. Like, don't do it. But in terms of like general health effects, nothing has been proven, nothing's been shown. There's not a significant link at this time. Arsenic, the antimony trioxide.
First it was energy, then the environment. Now what? Money. Saving money. When you see this.
That was awesome. I don't endorse anything he just said.
That was scientific research on phthalates.
Apparently somebody highly disagrees with me somewhere.
Pirate radio!
Antimony trioxide is also it's a contaminant that comes from the petroleum processing that can leach out, again, in high sunlight conditions, high acidic conditions, high temperature conditions. That is, again, why they say don't reuse it. Question?
The latest was don't freeze them.
Don't freeze. That freezing has not been proven at all. Like, there is no evidence that freezing it does anything in effect. The cold temperatures, in fact, inhibit the leaching of these chemicals.
Breathing. She said breathing.
No.
She said freezing.
I said freezing. No, I got an email.
The freezing, I think, is all from the part of water expands. It's going to damage the bottle. So that's all where it comes from.
Is it worse for pregnant women?
Oh yeah, we're at health effects. Forgot my disclaimers. I have 3 disclaimers for you. If you're pregnant, don't pay attention to what I say. If you're a baby, or you weigh under, let's say 5 kilograms, don't pay attention to what I say. If you have an immunosuppression disease, don't pay attention to what I say. And lastly, this is my favorite one. Does anyone smoke here? Oh, excellent. Well, if you're a smoker, you have bigger problems. So don't this is not in the same category as some of those behaviors. What do you guys think in terms of the scale of this? Are you worried about phthalates more than eating a cheeseburger at McDonald's? How do you weigh those? How do you study? Well, here's a great question. How do you think these studies are done? Anyone have any thought about how they figure out if it's bad for you or not?
Paid for by the industry.
Paid for by the industry. They're not, in fact. Not that I know. They have no interest in paying for those studies.
No, but yes, they have an interest in showing that their products are harmless.
As far as I know, none of the studies I've read has been funded by any private research.
The problem is generally laboratory testing overdoses rat, so that of course they have cancers or whatever.
That's a great point. High dose study. The reason they do a lot of high dose studies, it is quicker. It is cheaper. I would like to ask everyone this. So who is interested in taking part of a study where you drink potentially hazardous water every day for 15 years?
Oh, what do you think?
He thinks he's interested. It is unfeasible to run this study on humans at the kind of dosage that they're exposed to. It is financially and morally unfeasible. All these studies are extrapolations from rat data, from the studies on rats. The reason you see higher doses, again, it just makes it go a lot faster. Low dose studies are very difficult to conceive and manage. What I want to highlight is anytime you see a study like this, take it with a grain of salt, in that no one I know of has been researching this for 20 years. No study I've ever seen has been researching effective phthalates for 20 years. So, take it with a grain of salt. Anytime you see a study that claims that this is really, really bad for you, it invokes a change. That being said, I think this is a good foray into government policy. Let's see, I'll see if I pick up. Let's see if our friend decides to disagree with me. Who governs bottled water? The FDA, that is right. The FDA governs bottled water. The FDA's approach, if I could describe it really quickly, is innocent before proven guilty. So they're looking for evidence that phthalates harm humans in some significant, measurable way. We just discussed that proving that is going to be incredibly difficult. Incredibly difficult. So they operate on a principle, show us that it does harm before we do anything about it. Other countries operate on more of a precautionary principle, such as Canada and the EU. That's just the state of things in this country. We've shown that over a number of cases, that that's the way the FDA operates. If you want to make a single, I think, monumental change in this land, start lobbying how the FDA measures things and take more of a precautionary approach. Who wants more of a precautionary approach when it comes to these kind of leachates from plastics or uses of additives? Who's interested in more precautionary? Okay, only one person. That's why it's not going to change. I'm in favor of a slightly more precautionary approach because there are alternatives to this kind of. But the industry won't change until alternatives are sort of pushed onto them for some reason. Polycarbonate. Polycarbonate. What's the big bugaboo about polycarbonate? What's the leachate? BPA. What is BPA? It's bisphenol A. Why is it bad for you? No clue. Anyone know why it's bad for you? Replication of cells. I've actually never heard of it having that effect. The reason I keep asking what you know about it, where you've heard it, I think it's really important to highlight when it comes to all these issues around water. Where are you getting your information? How much do you actually learn about it? And how is it impacting your choices around water? A lot of this keeps coming back to an issue of trust in a lot of ways. Do you trust this? Like when you see an NBC report that covers this for 4 minutes that says, don't drink out of these, especially if you're a baby, and we don't tell you why, how does that impact what you feel about water? How does just like hearing the term BPA just float around, knowing it has a negative connotation for you? All right, so the actual science behind it. BPA is it's a chemical that mimics estrogen in your body. Big concern about it because there's a lot of studies ongoing that show higher estrogen levels, especially mimic estrogen, whatever the term is, like non-real estrogen production in your body, leads to greater breast cancer risk in females, significantly greater breast cancer risk. We've actually talked about this in another Science Cafe. It keeps coming up. So bisphenol A mimics estrogen in your system. They're very concerned about it from that standpoint. Bisphenol A comes from the repeated use of polycarbonate, where it gets damaged, and that's when it starts to leach more. It also leaches more at higher temperatures and higher acidic conditions. Tell me I don't sound like a record at this point. So, the studies. Back to the studies. So, by the way, this is a good little anecdote. How they found this out is they were studying wastewater, looking for drug use in cities. That's how they measure drug use in cities. And they found a spike that they didn't know what it was. So they figured out what it was, and they're like, where the hell is this coming from? And they backtracked it, and they figured out it was bisphenol A. and it was coming from polycarbonates. That's how they figured out there's something that we're carrying large quantities of in our body. So, where does what does this mean to you and me? The data currently is in conflict. It shows that low dosages, again, there's conflicting data on its impact. High dosages obviously has shown breast cancer incidence. Medium doses has shown tendency towards breast cancer risk. Low doses, conflicting data. But most of that conflicting data has to do with the weight. So under 10, 15 kilograms is the weight, shows that it has some tendency towards developing tumors. So what does that mean? They pull, in Canada and the EU, they pull all the polycarbonate that's used for pregnant women or babies immediately based on that. The FDA, our friends, is waiting for proof. That's the state of it. That's all I can tell you. Like, at this point, we don't know if it's actually that bad for you or not, because there's no way of telling. There's no one's going to come along and say, this is horrible for you. We can't commission that kind of study. It is a risk that you take. Now they make polycarbonate that doesn't have it in it. It's called like Triton, or they're like Nalgene and Camelback make non-BPA, BPA-free polycarbonate. It has something else in it. There's no guarantee 10 years from now we won't be in the same conversation about something else. That's just how things go. What I will say about that is this. Does that mean you should throw away every polycarbonate bottle that you have right now? What do you think? Yes. Yes.
What number is it?
7.
7. Oh, I thought the other one was 7.
No, this was 1.
Oh.
I would say no, because it depends on the frequency used and what temperature you're using it at.
Depends on the frequency used and the temperature used. How about it? What do you think?
Well, I might want to ask about other plastics. Like I just bought a multi-pure water filter, and it has a plastic casing on it.
The pure water filter has a plastic casing on it. I'll come to that in a second. Other plastics. But should you throw out your polycarbonate bottles?
What's the reason for the different numbers? I mean, what's the advantage of 7 versus 1? Why is it
The different numbers represent different product formulation. So this is not made in the same way that that is made. Why? Because plastics are all...
Number 7. Why would they just...
That is a misnomer. It is not for recycling. It's really a manufacturing code. Just because it has a recycle symbol on it doesn't mean it can be recycled. That's one of those little myths that just kind of sticks out at you. Because polycarbonate has a recycling code on it, this will not recycle. Like, they can't reuse this product. Anyway.
I've practically never seen a 7. Has anybody seen a 7?
Yeah. It's on every Nalgene bottle. But 1 recycles pretty well. We can talk about recycling rates later. But
why are they all ones then? I mean,
because this is actually a different chemical structure than that. So it's like how come aluminum and iron aren't the same thing? They're very different products. They're all under the name of plastics, but 1, 2, 3, 4, 5, 6, 7 all have very different processing. They don't all come from the same place. That's why they're
Yeah, but
differentiated.
he's asking, why would they not only use number 1, for example, to avoid the problem of the dangers
is
of
it cheaper to
7?
make 7? Is there economics?
Okay, there's economics here. Okay, so number 1 goes like this. It's like bendy and it's clear. And it's not necessarily the cheapest plastic out there, but it is the most, it's readily available because it's a byproduct of petroleum processing. So there's lots of refineries here in the States. It's an available product. This is more of the unbreakable material. It's hard, it won't shatter, it won't break, it stands up to repeated uses really, really well. Whereas this kind of breaks down a little bit after repeated use. So they each have their own functionality. Is 1 through 7 is basically what I'll tell you about it.
Part of the difficulty, I think, in evaluating risk on an individual basis is that none of us know where we fall on some normal distribution curve, whether we're in the average or whether we're super sensitive or whether we're not sensitive at all. So you hear a little bit of information about something being slightly risky. How do we know if it's slightly risky for us?
Okay, so the comment was, how do we know if it's risky for us? Because we don't know where we are on the distribution curve. You don't. Like, there's no way of telling. There's no way of saying that, Jeff, you're going to react worse to DHP coming off the number one than the woman sitting next to you. There's no way of determining that. They can only do this over a large populace. And all I can tell you is the data at this time shows that polycarbonate is a slight risk if you do repeated uses of it and you manipulate it under conditions. I would say in each of these cases, it's worse to have the bacteria stagnation than any of these chemicals leaching into it. You're more at risk in that way. Well, bacteria doesn't give you cancer? Bacteria does some bad things to you.
Now, a lot of water, you know, those big tanks that everybody buys and ships into their office. When you push the button, that draws in outside air to let the water come out. And that sits there for 5 to 10 gallons. And huge bacteria builds up.
That's true. Bottled water actually has a bacteria problem. A lot of them have, a lot of the newer systems have bacteria control filters in it. That's how they sort of deal with it. Bacteria count in tap water can be higher or bacteria count in bottled water tends to be higher than in tap water, purely from the stagnation standpoint. There's somebody's question I didn't get to. Your question? Oh, the pure filter housing. Inside of a pure filter or Brita filter, inside of a pure filter, the faucet mount ones, its contact time with water's contact time with the plastic is actually really low in those filters. What you end up doing is there's a small amount of water that sits inside the plastic for an extended period, but if you just kind of turn it on and now put your glass under there immediately, that water tends to go away. In Brita, again, it doesn't have a huge contact time with that initial plastic. The kind of the pitcher filter that you put inside of your refrigerator is made of polycarbonate.
Keisha, did you say with like a tabletop pure filter that the actual case of what it's sitting in is polycarbonate?
Wait, say that one more time. I didn't quite hear you.
Mine has a big countertop pure filter holding like 2.5 gallons.
Countertop pure filter, okay.
Maybe it's Brita.
Okay. It's like a little pitcher.
Yeah, it's not a pitcher. It holds a couple gallons. It sits on the counter with a little spigot on it.
Oh, yeah, okay.
Is that container likely to be polycarbonate also?
Yeah. It likely is, but you have to read the code on the bottom because there's some different plastics that are being used right now.
Are we going to be talking about water filters?
We can talk about whatever you guys want to talk about.
One thing I'd like people to mention, this is not right now, but when it's being time, is I saw a very interesting program about water treatment. And it was done by Free Speech TV and Nick. And it was like, showed about 35 to 36 steps of what it takes to clean water. This is just the wastewater to go into the bay. And most people have no clue how much energy, what it takes to clean water. You see it, your mind is blown away. It's absolutely incredible.
So it was really cool. We went on a tour of the wastewater treatment plant here as part of our ongoing treatment. So we got to see all those steps involved and what they could and couldn't handle. I think the part that sticks out in my mind is when they showed us the clean water at the end. It's still a little brown, just a little bit. And it gets pumped out a couple miles in the Pacific, but that's what's required. So I encourage you, there's great videos on YouTube. If you just type in like wastewater treatment plant, you can see all those processes up front and up close. What's your question?
Why don't we see aluminum cans being used for water?
Okay, the question is, why don't we see aluminum cans used for water? Why do you think?
I'd say marketing. It's clear.
I think you're right. Would anyone buy water in aluminum cans? No, why not? Tastes like aluminum?
It's difficult to reseal.
It's difficult to reseal. Those are all like right on. It is From the industry people I've talked to, it's generally a marketing thing. They like containers that are
What
clear.
about stick bottles, which seem pretty fashionable and are actually aluminum?
Yeah, this bottle right here is aluminum. Fashion, that's always a great component of this. Like, water does come down to be a fashion trend in a lot of ways now. And in terms of aluminum, there's no leachate that's been shown from any aluminum container. There's no significant studies that show anything is coming out of the aluminum. That being said, marketing people don't like these because you can't show how clean the water is, because you can't look into it.
But that's water, that's not soda or something more interactive with the plate.
That's right, we're talking about water tonight. We're not talking about my Diet Coke.
Stainless steel and glass that is ceramic, two surfaces.
I mean, that's all true. There's lots of surfaces that have shown no leachates at this point. Who knows 10 years from now where we're going to be.
It doesn't come back to that whole, when you're talking about selling water, I think you're right, it's back to the marketing. I mean, every water we buy in a bottle or something, you can see the water, it's clear, it's so pure, it's clear. I mean, how you can see the minerals anyways that are in there. That's why we don't buy water in stick bottles and whatnot, but like we use it ourselves. We take water out of the pure filter, out of the tap, out of whatever. But that's, it doesn't get sold in that. So I think that would mean, yeah, it's popular, but it's not being sold.
Hey, the giant point there is yes, we only buy water in clear containers right now. That is just the way they sell it. I mean, even non-clear liquids are being sold in clear containers, so you can see what's in there. I think it's a huge marketing angle, more than anything else to answer your question.
Okay, back to tap water, if we may, for a moment.
Back to tap water.
Having copper pipes versus old galvanized pipes like I've got. What's going on with the water I'm taking out of my tap?
What do you think the difference is? Why do you even ask about your different pipes? She asked about copper pipes versus galvanized pipes.
Well, I read once that in the olden days, people didn't get anemia because they were using cast iron skillets and things. This is what I've read. And I'm wondering up to what point it might not be good to have a little iron oxide in my water from my galvanized pipes, but I don't know.
Do you taste any difference?
It sure looks different, boy.
It looks different? How does it look?
Brownish sometimes.
Do you get brownish water?
Sure, out of my pipes.
She's talking about out of her pipes at home, she gets brownish water. What do you do with it? What do you do when you get brown water out of your
I
pipes?
try to let it run until it runs clear, but I don't know how.
So you just run it till it runs clear. That's generally the way you do it. Like, that's pretty much how the experts tell you to do it, and that's the only thing you can really do.
But how much of the copper from the copper piping and how much of the metal from the galvanized piping actually ends up in the water?
So that's a hard question to answer. Her question is, how much metal from pipes actually ends up in the water? It's very difficult because it depends on the metal and depends on the water. Water in Arizona is not the same as water here. So to talk about it here, it takes acidic water to break down copper or lead or any sort of galvanized piping. The only time we get pH water that is tending towards that kind of breakdown is when it's overtreated with chloramine, which we'll get to in a second. It's generally the pH level that is of concern is below 7, and I've never seen a water made out that low.
How does, in the domestic water supplies, we're seeing a lot of plastic pipe is used. So what's anything spinning off from there?
The question is about plastic piping use in domestic water supply. That plastic piping tends to be PVC, which breaks down a lot easier than the metal piping under certain conditions. There are lots of concerns about using PVC piping for this.
But municipal water supplies are using that quite a bit.
They are using it quite a bit. It tends to be used before any disinfection is applied, before chlorine is applied. But that being said, there are concerns about it, and it's always acidic environments again that tend to break down PVC. A lot of the concern about PVC, though, is I personally think happens to be the wear and tear on it again. But it's so much cheaper. and it's so much easier to replace. What's your comment? You hate PVC, I can tell.
No. It's just that for 30 years, I've never fully trusted municipal water supply to deliver to us as clean a water as I think our bodies deserve. And from Crystal Springs Reservoir, we get asbestos from naturally occurring bedrock. There's things like that I've always protected against, and I've always used what's called an iron. You're selling much anything, but a solid block of carbon, not granular. Never buy granular. Which filters down to 0.04 microns, and hello. I've always had on my kitchen tab and bathroom, adapted, solid block of carbon. And it's, Multipure was this corporation that for probably 50 years now, and then they became commercial with little folks like us, but they did hospitals and airlines and whatever. But it's a solid block of carbon that takes out heavy metals and, of course, all the chlorines and things.
So let me cut it.